This lesson is on applications of exponential functions, which of course means word problems. We're going to be taking a look at a couple of different word problems today, generally involving exponential growth or exponential decay, and then we will move into compound interest and continuously compounding interest. So the problem that we have in front of us is about the value of a car. Please feel free to pause this lesson when you need time to work to follow along. A car goes down in value by 10% each year. It was worth $20,000 upon purchase. So, if we're looking for the value after a year, we know that the value of the car is going to be $20,000 times 90%. 90% of $20,000. We get 90% by taking the 100% it was worth and subtracting 10%. Now, in a multiplication problem, we would write that instead as 0.9. So the value of the car is $20,000 times 0.9 or 0.90, which is $18,000. Think for a second about what the value would be after 2 years. The most common wrong answer to this is that the value would be $16,000, that it would decrease by another $2,000. If it were to decrease by $2,000 again, we wouldn't have an exponential function, we would have a linear function. So what we need to do is we need to take the value of the car, which is now $18,000, and multiply that by 0.9 again. It's again going to be worth 90% of its value. That's going to give us $16,200 for its value. Do you notice the pattern that we are doing here? We are going to take our initial value and we are going to multiply it by 0.9. After we do that, we're going to multiply that by 0.9 as well. Each successive year would have us multiply by 0.9 again. When we have repeated multiplication, instead of writing all of those multiplication problems out, we would instead write those 0.9s as 0.9 raised to a power. So each year would be a new power. After x years, it would be 0.9 to the x power. There are a couple of things that we can look at before we move on from this problem. Each one of these values has a different name and a different role inside the function. 20,000 is our initial value, and it's also our y-intercept. If I plugged in x equals 0, I would get a y value of $20,000. 0.9 is called our decay factor, and it is our decay factor because it is the number that we are continually multiplying by. Remember, the number that we raise to a power, the base, is called our factor. And we know this is exponential decay for two reasons. One, the value is going down, and two, the factor is in between 0 and 1. If we were to graph this function, it would look like this. So over time, we can see that the function is decreasing. It looks almost linear, but you can see that there is a slight curve to it. So by the 5th year, the rate that the value of the car is decreasing has slowed down just a bit. Now we're going to look at a growth problem. We can tell this is growth generally because it's about gaining money. We are told that we have a rate of 2.75%. Now we always want to write our rates as decimals. So to convert that to a decimal, we would write it as 0.0275. Remember to move your decimal place 2 to the left. Now if we wrote that in parentheses, if we were to continually multiply by 0.0275, we would find ourselves getting smaller and smaller numbers. To show that this is a growth problem, we need to remember that we have 100% of our money each year and we are getting another 2.75%. So each year we are going to have 102.75% of our money, or we're going to be multiplying our initial value by 1.0275. Doing that once is going to give us our value after 1 year. That value is $616.50. I'd like it if you would always write monetary answers to 2 decimal places and always rounding down the second or the last penny. After 2 years, we would be multiplying by 1.0275 2 times, or squared, and that would give us $633.45. Now, see if you can figure out how much money you'll have in the account when you graduate college. This is obviously going to be a different number depending on what year you are in school now and how many years you're going to take to graduate college. If you're going to graduate college in 5 years, so that would be you juniors who are going to graduate in 4 years, you would have $687.16. If you're going to graduate college in 6 years, you would have $706.06. I'm going to put up the formulas that help us find the answers to these questions. However, hopefully you don't need a formula to do these simple questions. So here are the formulas. If you could pause on this screen to make sure you write these down, just so you know, these are ones, not L's. Okay, take a look at that for a second. The reason these problems are important are because they allow us to see which investment, for example, would be a better choice, which investment would give you a higher return. Assume for these problems that I'm only interested in getting a maximum amount of money and that I'm not going to worry about, you know, whether I would rather have the money in 4 years or 7 years. See if you can set up both of these problems. Remember, these are written as percentages, and we're hoping to gain money. So the percentage needs to be somehow figured in to make it a growth problem. Alright, pause the video now until you have those written. Hopefully you figured out that the growth rate for each of these problems is its percentage expressed as a decimal. So for choice 1, we would take our initial value times 1 plus the rate, and then we would raise that to the 7th power. For the second one, we would have our initial value times 1 added to our growth rate, and we would be raising that to the 4th power. So choice 2 just barely edges out choice number 1, but it is the better investment by about $2.